Hello and welcome to another episode of our Deep Dive AI webinars. I'm Stefano Maffulli, I'm the Executive Director of the Open Source Initiative, and today we're going to hear from Christy Whitaker, Professor David Leslie, and Victoria Kwan about operationalizing the safety principles for open source AI. Stay with us, hope you enjoy, and we're going to be taking questions at the end.
Hi, everyone, and thank you so much for joining us. I'm delighted to be representing the Alan Turing Institute, the UK's National Institute for Data Science and Artificial Intelligence, at this Open Source Initiative Deep Dive, Defining Open Source AI. Two of my colleagues are going to join me in presenting to you. Professor David Leslie is going to get us started. He is the Director of Ethics and Responsible Research and Innovation at the Institute, and he's going to be defining the safety principles that have come from public sector advice published in 2019. And then Victoria Kwan is our Corporate Governance and Research Ethics Manager, and she's going to talk about how we have operationalized those principles into an end-to-end process for our institute-wide research ethics review. And then I'm going to finish up by thinking about how we can take current open source ways of working and use them to deliver on the open source, the safety principles for a fully open source AI workflow. So thanks very much for joining us. David, take us away.
Hello, my name is David Leslie. I'm the Director of Ethics and Responsible Innovation Research at the Alan Turing Institute and Professor of Ethics, Technology and Society at Queen Mary University of London. I should say we are so grateful to be here with you today as part of Open Science Initiative's Deep Dive AI webinar series. And our webinar today will be on the safety principles. So first, I should just say, what are the safety principles? The safety principles are a set of practical principles or actionable normative goals that can be operationalized within AI design, development, and deployment practices and research practices to ensure responsible and trustworthy research and innovation activities. The safety principles themselves come from some ongoing research and collaboration that's been undertaken over the past few years within the public policy program at the Alan Turing Institute, specifically in our collaborative relationship with the Council of Europe, where we've authored the zero draft of the Council of Europe's upcoming Human Rights, Democracy, and the Rule of Law Impact Assessment for AI systems, and the safety principles are part of that impact assessment. They've really formed a large aspect of how we are applying actionable normative goals to governance processes and governance mechanisms. So I should say that the safety principles, the safety part of safety principles is just an acronym for safety, accountability, fairness, explainability, and data stewardship. And so what I'll do is I'm just going to run through each of those headings and sort of describe what they include. So first of all, say the heading under the heading safety, we think about elements like security, so ensuring that a system maintains its integrity amidst any type of attempted breach of a system. Reliability involves a system being able to maintain its intended functionality when it's operating in the wild. Robustness involves a system that's strong enough to withstand kind of unknown unknowns or unforeseen circumstances or adversarial attack when it's operating in the world. Accuracy and performance is just that. So it's just ensuring that a system is performant, that it's got that it lives up to performance metrics like precision or accuracy or what have you. And lastly, sustainability or social sustainability involves assuring that projects are responsive to dynamic socio-technical environments and also continuously sensitive to real-world impacts. And so when we talk about the social sustainability of the system, we're really talking about a system having sufficient anticipatory reflection on possible negative impacts, possible long-term harms that a project can do. Second, we have accountability. Now, accountability involves assuring that that there's a kind of end-to-end answerability and auditability framework in place, as well as mechanisms for actionable recourse and redress, and that these have been integrated into a research and innovation workflow. And when we talk about accountability, say accountability by design, we're talking about having processes in place that make sure that the humans who are involved in the innovation processes are going to be held answerable for their activities, and that you've got a system that's auditable from beginning to end. And another way we talk about accountability is as process transparency, so that the processes behind design, development, deployment are sufficiently transparent and therefore able to be held accountable. Next is fairness, and assuring fairness means assuring that AI projects are non-discriminatory, that they mitigate unfair biases across the entire project lifecycle, and that they support equity, equality, diversity, and inclusiveness. And you know, it's really important to really stress that sort of fairness or non-discrimination by design does involve an entry point from the very earliest stages of project conceptualization straight through to the maintenance and retirement of a system, because issues of equity and bias can appear at any point along that whole research and innovation life cycle. Next, we have explainability. And so explainability really involves assuring that AI projects and research are able to provide clear, accessible, and relevant information about both the rationale or logic underlying a system's output or a research output, model's output, but also about the innovation processes behind those outputs. So it has to do both with being able to show that you have a system that is sufficiently interpretable for the purposes of the research and innovation, but it also means having mechanisms in place so that you can explain that the innovation processes have been undertaken in safe, responsible, and fair ways. And so explainability has that kind of double-barreled character. Finally, data stewardship. This involves assuring that there's sufficient data quality, sufficient data integrity, sufficient data privacy, and that data protection has been fully and thoroughly approached, and that the project is compliant with data privacy and protection laws. So that is the kind of big picture of those kind of safety headings. Now, let me just close by really exploring the possible governance actions for operationalizing the safety principles, and these are just some recommended or possible mechanisms to put into practice these top-level normative goals that I've just been speaking about. So first, safety. So one can engage in safety self-assessment and risk management processes. These processes will facilitate evaluation of how AI projects and research align with the safety objectives through iterative identification and documentation of potential safety risks across the entire life cycle, as well as assurance actions that have been implemented to address these. For sustainability, as I mentioned before, this kind of responsiveness of a system to the changing environment and social context. We have first possible stakeholder engagement process, which is a process for facilitating contextually informed understanding of the social environment and human factors that may be impacted or that may impact individual AI projects. and also stakeholder impact assessment or some form of impact assessment, which will facilitate iterative evaluation of the social impact and sustainability of individual projects and research. Now for accountability, as I've spoken about before, an accountability framework really involves process-based governance. And so having a process-based governance framework is very important, and also logging protocols. And so process-based governance framework would involve live documents, documenting of governance actions, of relevant team members and roles involved in actions, of timeframes for follow-up actions, and other dimensions of logging protocols. And it's really important to have a type of logging framework in place to ensure sufficient evidencing and documentation. For fairness, we have potential bias self-assessment and risk management processes, and these processes are intended to facilitate the evaluation of how projects and research aligns with the various principles of fairness that are being put into practice. And it does this, bias self-assessment and risk management does this through iterative identification and documentation of risks of bias across the entire life cycle, and also documenting assurance actions that have been put in place or implemented to address any identified biases. The other fairness mechanism is a fairness position statement. And so if you have any models or systems that involve what we call metric-based fairness, so determining a metric that will guide the allocation of outputs or the distribution of error rates, for instance. When a decision is made about any type of fairness metric, a fairness position statement basically makes explicit what the rationale behind that decision for the metric is. Now, just to say, to move on to explainability, or transparency in that explainability sense, we've got a sort of an explainability assurance management mechanism. And this would involve just displaying that a kind of explanation-aware process has taken place, so that decisions about the interpretability of the system have been made deliberately based upon the needs of those impacted by the system, and that you've considered all of the issues around having a sufficiently transparent or non-opaque system for a given context. And then finally, in terms of data stewardship, you need to have some form of documentation mechanism. And one possibility is a data fact sheet, for instance, which involves a kind of live documenting of the best practices for responsible data management and stewardship across the entire project or research workflow. And this would involve documenting or keeping a comprehensive record of data lineage and iterative assessment of data integrity, quality, privacy, and protection. So let me leave it there, and I'll leave my colleagues to explore in more detail some of the other dimensions of putting safety into practice in research. And thanks so much for sharing. I hope you get something out of the webinar. Thank you. Take care.
Thank you for that, David. My name is Victoria Kwan, and I'm the Corporate Governance Research Ethics Manager at the Alan Turing Institute. In this next section, I'll give you a high-level overview of how we have operationalized the safety principles at our organization. So to turn theory into practice, we've embedded the principles into the Turing Research Ethics Review process, which is otherwise known at our organization as TREX. So researchers at the Turing who are working on original research must apply for a TREX ethics approval before they can begin material work on their projects. The TREX application asks researchers to consider the principles that David talked about in the context of their own projects. And the questions that we ask through TREX really encourage researchers to demonstrate that they have, 1, considered the real-world impacts of their work, 2, fostered a culture of responsible research across the whole project team and the whole project lifecycle, and 3, put into place governance procedures that ensure accountability. Next, I'll quickly take you through the questions that we ask of our researchers on the TREX application form. In our section on sustainability and safety, first of all, we ask researchers to identify the stakeholders of their work, the real-world impact that their work is expected to have, and any groups that might be particularly vulnerable to the anticipated impacts. If the research team has conducted a stakeholder impact assessment, this would be a great place to note that. Applicants should also explain the stakeholder engagement methods that they're using. So whether that means informing the stakeholders, consulting with them, partnering with them, or empowering them, as well as any mitigations that they have in place to address the potential negative impacts of the work. We also ask our researchers to reflect on the possible environmental impacts their work may have, which might be particularly relevant for some projects where significant amounts of compute resources are being used. And we ask the researchers to describe any potential mitigations or justifications that they have. For our technical sustainability question, we're looking for applicants to discuss the steps that they've taken to ensure accuracy, reliability, security, and robustness, and to acknowledge any limitations and identify possible mitigations. If the research team has conducted a safety self-assessment or a risk evaluation describing how their AI projects align with safety objectives, this would be the perfect place to state that on the application. And to close out our sustainability questions, researchers are asked to reflect on the well-being of not just the participants in the research, but also of the research team itself. So is there a possibility that the work might have potential negative impacts on researcher safety or mental well-being? And if so, what are the mitigations and the guardrails that the research team will put into place? So next we have accountability. And we will have some questions about answerability and auditability. And the questions here are all about ensuring that our researchers are able to justify the decisions they've made throughout their project, and that each decision is attributable back to specific individuals. So here the researchers will have an opportunity to explain their governance procedures and their logging protocols, explain how the roles and responsibilities have been assigned to team members, and explain how, where, and when project decisions will be made accessible for audit and review by parties external to the research team. We also want to encourage our research teams to make their data, code, and documentation available to other researchers where it's legally and ethically permissible to do so. So to that end, we have a question asking applicants to elaborate on where this will be held and whether and where process logs will be kept for future replication and reproduction. In our fairness section, we have questions about data fairness, where researchers can explain their methodology and the data sets they're using, the recency of the data, the provenance of the data, and whether metadata and contextual information will be attached to the data, as well as any steps that the team has taken to ensure data integrity. Our design fairness question asks applicants to reflect on whether and how all voices on the research team have been included at the project design stage. So here the researchers can describe the recruitment process and how the team was put together, the team structure, the team culture, and how the team will ensure that everyone's ideas are heard and contributions acknowledged. It's also important for our applicants to be able to articulate the definition of fairness that they're using to measure the outcomes and impacts of the project. So for some research projects, this may mean describing a mathematical definition of fairness that they're using. If the team has written out a fairness position statement that establishes the metric-based fairness criteria for the project, this would be the place to mention that. If the team has conducted bias self-assessments, we would also love to know that. For certain other projects of the Turing that are not quantitative, and so if it's a project involving qualitative methods such as interviews or focus groups or surveys, fairness might not be a mathematical definition in that context. Rather, fairness might mean something else, such as ensuring that the groups of interviewees that the researchers are engaging with are representative and diverse, and do clearly represent the population that the researchers are drawing conclusions about. But the important thing for this question is that the researchers have reflected on what fairness will mean in the context of their work. And to close out the fairness section, the researchers will be asked to explain how and where they will be communicating their findings, how they'll acknowledge the limitations of the project methods, and whether they are planning on providing trainings and explanations for on-the-ground users. This leads into our explainability and transparency questions. And here's where our applicants will have the opportunity to further elaborate on how they are ensuring that these outcomes are interpretable and explainable to the stakeholders, and if the research involves building AI systems and for the system users as well. Finally, our applicants seeking ethics approval from the Turing do have to affirm that their research will comply with the Turing's data management policies and our data protection processes, as well as our legal and contracting procedures, our open access and open sourcing policy, our open publication policy, research misconduct policy, and code of conduct. So that was an overview of what the TREX application looks like. And next, I'll explain the process a little bit. So once our research team submits a TREX ethics approval application, we have a two-tier review system in place. First of all, the application will go to 2 TREX reviewers who have been drawn from a pool that consists of researchers based at the Turing Institute and also Turing Fellows who are also researchers based at different universities across the United Kingdom and who are affiliated with the Turing. These 2 reviewers are responsible for assessing the answers on the application, providing feedback, and making recommendations on the project. Then the 2 reviewers' assessments go up to the TREX panel, which is a decision-making body that consists of both Turing staff and Turing Fellows. The TREX panel meets 6 or 7 times a year to discuss ethics applications and to issue approval decisions. And the ethics decisions and feedback on the projects are then communicated back to the applicant. There are several possible decision outcomes from the TREX panel. The first option is outright approval. And so this is granted usually for projects that implicate no or few ethical concerns. The next option is conditional approval. So this is for projects where there are some ethical concerns, but these concerns can be mitigated against as long as the research team has put the right safeguards into place. And in most cases, from the ethics applications we've seen at the Turing, the TREX panel will grant either outright approval or conditional approval. In rare cases where there are particularly challenging or ethically complex projects, the TREX panel can choose to escalate these projects to the organization's CEO for their opinion and for further discussion. So that, in a nutshell, is how the Turing has operationalized the safety principles that David discussed. The TREX process encourages researchers to engage in critical self-reflection about the impact of their work and how the work is conducted. And we really do strongly believe that incorporating these principles into every stage of the project lifecycle will enable better research and also support our researchers in the great work that they do.
Hi, everyone. I'm delighted to follow David and Victoria. My name is Kirsty Whitaker, and I'm the Programme Director for Tools, Practices and Systems at the Alan Turing Institute, and I'm also the chair of the TREX panel that Victoria was just telling you about. What I'm going to do in this final presentation is, I hope, help you to see how we in the open source community are already following practices that underpin the safety principles for responsible and ethical AI. Let me start with a quote that really motivates why I care about open source so much. Sunlight is the best disinfectant. One of the biggest frustrations that we all have about AI workflows at the moment is how non-transparent their processes are. So whether that's a lack of computational transparency, or where the data are coming from, or decision-making, or the labor related to training the models, I want to put to you that we would build a better, safer, more diverse AI ecosystem if we brought as much of that work and those processes as we can into the open. I suspect, as you're here, you will agree. So a bolder statement, I think, that open source practices are already available to deliver safe and ethical AI. And the slight caveat here is that it depends a little bit on how you define open source. And obviously that's why we're all here. And I'm so delighted that the OSI is facilitating this deep dive and we're getting to have these conversations as a global community. So what I'm going to do in this talk is I'm going to go through the safety principles, and then I'm going to sort of show how they already link to existing open source practices. So starting off with safety and sustainability. I wanted to pick an image, a seasonal image. It's October 2023 when we're recording this. And the quote that I picked for this one that many of you will already know is that given enough eyeballs, all bugs are shallow. And this is Linus law, and it was codified in the Cathedral and the Bazaar by Eric Stephen Raymond. And this is really a fundamental building block of free software, a precursor to open source software. And my point is here that it's really been around from the very beginning, that having as many people as possible participating in the creation of some tooling makes it easier to keep it safe and moving forward to meet the needs of the users and the developers. So if we're thinking about building a definition of open source AI that is safe and sustainable, I would say that we need to have a broad and engaged community involved throughout the development workflow, and that will facilitate us in keeping the infrastructure more secure and keeping the purpose of the work aligned with the needs of the impacted stakeholders. So I think what we're doing here is thinking just a little bit more broadly than current thinking and sort of implementation of these practices that probably consider the users and the developers, but maybe don't necessarily think about the people who are impacted by the outcome of the work. But I would say the practice is still the same, and we just need to kind of keep bringing as many people in to those conversations as possible. And that leads me on really nicely to thinking about accountability. And my quote here that I've picked is from a history of the request for comment that came from ARPANET, which was a precursor to the internet that we currently know and mostly love. And Stephen Crocker has written about the fact that when they first started thinking about how to build this sort of system, they wrote down some ideas, and they really tried to reinforce that anyone could participate in sort of refining these ideas. And so he wanted to really emphasize that although it was written down, nothing was official, nothing had been decided. And so to really sort of make sure that that point landed, he labeled the notes as request for comment. And the reason that I bring that up now is that I think one of the biggest problems of closed source AI is that there's no documentation covering how decisions are made, how changes could be suggested, how the model or parts of the workflow could be adapted, maybe to other languages, how the workflow, the whole sort of pipeline of development could be improved. And importantly, there's very, very few pathways for how concerns can be raised. And I don't want to suggest that open source has sort of solved the problem of accountability. I think actually the fact that there aren't institutional backing for some of these responsibilities is probably a challenge faced by open source projects. But I think we do have some really good solutions here. We have asynchronous participation in the development through, for example, GitHub or GitLab or other discussion spaces. We have version control, we have requests for comment, and I also want to shout out a huge amount of work that's been going on thinking about codes of conduct for facilitating participation from a diverse group of people in building and sustaining open source tooling. And thinking about that diverse group of people that need to be part of this sort of strategy setting and part of the decision making of a project takes me into considerations of fairness. And this quote you may not know, I hope you like it as much as I do. It was said to me by a friend of mine, Dr. Tion Brooks, who is a data scientist and was a Mozilla Fellow for Science with me back in 2016. And I always remember it because I love the idea that we are building not towards having a really, really good diversity committee, but in fact to getting rid of the diversity committee, because every team that we have has diverse representation and are considering challenges around equity, diversity, inclusion, and justice at every level. And before I go on, I want to quickly shout out another OSI deep dive that members of my team at the Institute who lead on the Turing Way project brought together, and they asked the question of who is building open source AI. So please do check out that recording. I'm particularly proud that we had Moffat, who is representing the African Content Moderators Union. I think their voices are some of the most marginalized in our current AI development workflows. And I'm very, very proud that we had such a great team of people representing the diverse perspectives of people who are really building open source, who are really building OI, who are really building AI, and who I hope that we can credit much more transparently as an open source AI ecosystem. So going back to thinking about fairness, we want to make sure that open source AI can clearly communicate how the AI model and workflow are considering equity and justice at every level. And I'm also very passionate about thinking about how we can reuse thinking that's already been made available. So there are tools that already exist for sort of interrogating biases and helping people to sort of reflect and think in a structured way about the biases that are already inside of data sets. And if the open source ecosystem continues to build in an interoperable manner, then we can reuse those tools rather than needing to reinvent the wheel for every individual project. I don't want to say that we can outsource fairness to a statistical solution. I think fairness is much, much deeper, and I think it requires a great deal of human reflection. But I do think it's possible for us to stand on each other's shoulders and scale the knowledge and expertise that already exists through an open and interoperable ecosystem. So by working together, I hope that we can really make progress in dismantling and deconstructing the biases that are already baked into our systems, baked into our world. So interoperability brings me to explainability. The quote that I've chosen here appears in so many talks about open science or open source software for science that probably someone somewhere is going to have to take a drink to the end of their beverage on this slide. So have a shot of espresso right now. I'm going to read the full quote. I've only put the last part of it on the slide. An article about computational science in a scientific publication is not the scholarship itself. It is merely advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures. And this was from an article by Buckheit and Donahoe quite a few years ago now, but always worth returning to. So if we think about explainability, the ability to interrogate all aspects of a workflow is, in my opinion, one of the foundations of the definition of open source. Access to the source code, access to the data, thinking about the documentation that tells you how to sort of link those two together and reproduce findings that have already been communicated. So I would say that our current open source ways of working will enhance transparency and as a result take us very, very much further along the pathway to explainability, because we'll be able to kind of report to the people who are affected by the AI models how decisions about the outcomes are reached. My last bullet here is around data stewardship. And that's thinking about the fact that digital assets should be findable, accessible, interoperable, and reusable. This is a huge area. I know there are other presentations as part of this deep dive that are digging into it, but I do want to shout out the fantastic work of the library science community and other data practitioners around a very, very diverse ecosystem that published the FAIR principles, that are making sure that we are learning from our colleagues from lots of different domains and making sure that those digital assets can be, as it says, findable, accessible, interoperable, and reusable. So one of the areas where I think the open source community hasn't necessarily engaged really deeply in the AI ecosystem is around data stewardship. And I think that's often because either the data itself is fully publicly available, which may or may not, in fact, be an ethical decision, or the data is closed and therefore not open, and therefore open source developers don't necessarily sort of see it as their responsibility to think about that. And what I want to highlight here is that metadata standards allow for interoperability and transparency, even where data cannot be made openly available. And it's rare that metadata can't be made openly available in an ethical manner. Usually it's only kept confidential for commercially competitive reasons, and therefore I don't think that fits into an open source AI definition. They could keep the data closed, but I don't think keeping the metadata private fits with a definition of open source. And there are also a couple of examples related to kind of using data for defense and security purposes. But again, I think we would need to ask a question of whether that should be open source. I don't think our definition of open source AI needs to include applications that really just are not and should not be open source. So we can think about accountability, fairness, explainability, reproducibility, the way that data is created and governed as a way to interrogate what we have going in to the AI development pipeline. Our goal is not to have garbage in and garbage out. What we want to have is high quality, ethically managed and well curated data going in to an open source workflow, and that will lead us to a much more effective and efficient and hopefully just output from the model itself. So I've reached the end of my presentation, and I just want to leave you with a few thoughts about what we as an open source community need to stop, start, and continue doing. So we need to stop thinking of ourselves as separate, disconnected individual people and projects. And we need to stop avoiding responsibility around data governance and avoiding the responsibility to credit the people who are affected by the tools or models that we build or contribute to building. And related to that, as we stop doing those things, we should start building an accountability for decisions across a whole AI development workflow. So instead of just the one particular module, we need to be thinking about how that module fits into a full AI workflow. And we also need to start explicitly connecting data processing responsibilities with bias mitigation reporting frameworks through the tools that we build. So really taking on that accountability, taking on that responsibility all the way through. And importantly, though, I want us to continue working transparently, continue building diverse communities, continuing documenting governance decisions, continue supporting maintenance and infrastructure work, and continue to scale access to knowledge worldwide. I'm really, really proud to be part of the open source ecosystem, and I'm delighted to be advocating for it with you all going into the future. So thank you so much for listening to these, to participating in the webinar. We really look forward to any questions that you have. Please feel free to send them to us offline as well if you're watching this as a recording. And I'll just finish by thanking so much my colleagues, Professor David Leslie and Victoria Kwan. And thank you for listening.